this moment in technology around the growth of AI sort of reminds you of some of the important transformations in the past?
Here we are in some crazy sort of hyperdrive Moore's law, right? And so I'd say maybe 20-30% of the code that is inside of our repos today in some of our projects are probably all written by software.
And I mean, I tend to think that like every engineer is effectively going to end up being more of like a tech lead in the future that has sort of their own little army of
That's
engineering
right.
agents that they work with.
Welcome to the boardroom. Today we're breaking down what I'd call the AI State of the Union. So this is a conversation between Mark Zuckerberg and Satya Nadella, the CEOs of Meta and Microsoft respectively. And this conversation took place a few weeks ago at LlamaCon, which is Meta's developer event. And honestly, it's one of the most insightful discussions on AI I've seen, especially from two people actually building at the top of such big organizations. So combined, these guys oversee over 5 trillion in market cap. And we're going to cover everything from why AI is moving so fast to real world use cases and how companies are actually using AI, all the way to, where does this actually go from a measurable economic perspective? So with that, let's jump into it and start reviewing.
Anyway, so you've said a number of times that this moment in technology around the growth of AI sort of reminds you of some of the important transformations in the past, from going to client server and the beginning of the web and things like that. So I mean, I'm curious to unpack
So
that.
for me, I grew up when sort of the client was being born. I joined Microsoft just after Windows 3, and so I saw the birth of client server, then the web, mobile cloud, and then you could say this is the fourth or the fifth, depending on how you count. And it's interesting, right, which is each time there is this transition, everything of the stack gets relitigated. And you get to sort of go back to the first principles and start building. I thought, like, even the shape of the cloud infrastructure, for me, that I built starting, let's say, in 2007, 8 to what have you, the core storage system for training doesn't look like the core storage system you built. Or this workload of training, right? The data parallel synchronous workload is so different, let's say, Hadoop or what have you. So the fact that you kind of have to rethink everything up and down a tech stack with each of these platform shifts is sort of what I think we face from time to time. It sort of grows from what was there. The web was born on Windows, but it went far beyond that. That's kind of how I think about this as well.
So I really like that quote and kind of core idea from Satya that every time you have a transition like this, everything in the technology stack needs to get relitigated. So whether it be, when PC or the internet or the cloud became really prominent, it's not just how we interact with these tools, but the entire stack that needs to be considered. And I think a lot of people and a lot of companies are approaching AI as let's just bolt on ChatGPT. But really, there is a much broader conversation. How do you architect systems? What do you do, again, bottoms up to make AI successful? So really interesting perspective there.
Yeah, that makes sense. I mean, you've made this point a bunch of times around how as things get more efficient, it changes the way it works, and people just end up consuming a lot more of the services, right? And I guess one of the things that I'm curious about, right, because you guys are in this great enterprise business, and we don't have as much visibility into this, is sort of how you're seeing that play out around all these AI models, right? You're seeing like generation over generation, they're just getting so much more efficient and delivering more intelligence than the last generation. And obviously it's all happening super quickly. So I'm not sure kind of what you see in that, but.
So this is a really interesting concept, especially since AI was so cost prohibitive in the beginning, that now that these models are getting better, even though they're technically using more compute, more resources, people are using way more of them and costs are coming down. So he also gives Satya his flowers here and talks about the enterprise business that Microsoft runs. So let's hear what his reaction is.
How what you see in that, but
Yeah, I mean, if you think about it, right, which is, yeah, we were all, a few years ago sitting around and saying, oh my, what's happened to Moore's Law? Is it over? What do we do? And here we are in some crazy sort of hyperdrive Moore's Law, right? And it's always been also the case, right, which is any one of these tech platform shifts has not been about one S-curve. It's been multiple S-curves that compound, right?
Right. So I love this allusion to Moore's Law. So just for context, Gordon Moore, one of the co-founders of Intel, observed that the number of transistors on integrated circuits was doubling approximately every year. So what that really just meant was you had exponential growth in computing power and overall innovation. And for a long time, especially recently, people were saying, that concept is dead, right? Really more in principle. But now with AI, we've seen that even compound further. So, what I think Satya points out here that's really insightful is it's not just one thing, right? It's not just the chips getting better. The models are more efficient, prompting is more effective, software is more optimized, and the overall cost per inference in improving things is just coming down drastically. So I think that the other insight that he provides is the concept of S curves and multiple S curves compounding. So an S curve refers to how innovation scales. So essentially you start slow, it hits a breakout phase and then matures. So when you kind of plot that on a graph, it resembles an S. But in AI, you're not just seeing one of these S curves, you're seeing 5 or 6 of them all converging, all peaking at once. So that's a really practical explanation to why AI is moving at this kind of breakneck pace that it feels like it's moving at right now. It's not just one thing happening. Again, it's not just chips, it's not just models, it's all of these things layering on top of each other, compounding. And the next clip is also really interesting because he starts to break down exactly where those S curves are coming from. So let's jump into that.
Curves that compound, right? Even if you take just the fact that the chips are getting better. People like Jensen or Lisa are doing tremendous innovation. Their cycle times have gotten faster. So let's say that's Moore's Law. But on top of that, everything at the fleet, the system software optimization, the model architecture optimizations, the kernel optimizations for inference, the app server, even the prompt caching, how good we've gotten in. And so you add all of that up for every 6 months, 12 months, you have a 10x perhaps improvement, right? And so when you have capability improvement of that rate and the prices drop at that rate, fundamentally consumption goes up.
So this is where Satya gets into the specifics of those overlapping S curves. So he name drops Jensen Huang at NVIDIA and Lisa Su at AMD, basically calling out that the hardware is evolving faster than ever. But again, it's not just about chips. He goes down the list. The software is getting tighter. Model architectures are getting more efficient. Kernels for inference are being improved. Even prompt caching, so like how you look at prompt history, is improving. So all of those things coming together at once, you don't just have a better model, you have a better ecosystem that's 10 times faster, cheaper, and more scalable every 6 to 12 months. So that leads to really 2 things, right? One, massive acceleration of AI capabilities, but then 2, also the explosive demand for those capabilities that we're seeing across the enterprise, developers, consumers, everything. So like Mark said earlier in the video, as AI gets more efficient, the more everyone builds with it, the more everyone wants to use it, and it creates that feedback loop. And that's really the moment that we're in now.
Microsoft obviously has been on this interesting journey around open source, right? And this is one of the big things that you did, under your leadership early on, was embracing it. And you had the early partnership with OpenAI, but then also were very clear that in addition to working with closed models, you wanted to make sure that Microsoft served open models well. And I'm curious how you think about that and how you think that the open source ecosystem is going to evolve and why that's important to your customers and how you think about that with all the infrastructure that you're building.
Yeah.
All right, so here Zuck is basically talking his own book. So he starts to push the importance of open source AI models. And that makes sense because Meta's entire Llama model, which is basically their own family of models they've developed, is open weight. So, quick context on that: open source in AI basically means the model weights or the actual brain of the model are freely available. So anyone can download it, fine tune it, and ultimately deploy that themselves. Now, that's a big contrast to models like ChatGPT's GPT-4, which are closed off. And Meta's strategic bet here is a smart one, right? So, one, if developers build on your models, you own the ecosystem. And then two, unlike Google or OpenAI, Meta isn't trying to monetize the Llama models directly. They're playing the long game and they're basically saying, hey, let's make Llama the Android of large language models, free, flexible, and everywhere. So this is part philosophical, part tactical. And in second here, Satya is going to come in with a very different but complementary view from the infrastructure side, which is more pertinent to Microsoft.
It's interesting you ask that because I grew up, in fact, one of my formative jobs at Microsoft was also making sure that we had interoperability with the various flavors of Unix out there between NT and Unix. And that taught me one thing, which is interoperability is what, first of all, customers demand. And if you do a good job of it, that's good for your business, and obviously you're meeting customers where they are. And so to us, I think that's what has shaped my thinking when it comes to open. I mean, I'm not dogmatic about closed source or open source. Both of them are needed in the world. And in fact, I think customers will demand them, right? Even if any one of us has dogma, it doesn't matter, because at the end of the day, the world will break that way, which is there will be a need for it. So given that, I think, like, for example, there was SQL Server, there was MySQL, or Postgres. There's Linux, there's Windows. In fact, there is Linux on Windows. In fact, my favorite thing to use is WSL on Windows, because it just makes it easy to take a lot of the dev tools and deploy them on Windows. So overall, I think having a posture that allows you to mix and match these two things is super helpful.
All right, so here you can see a pretty pragmatic and strategic approach from Satya. So after Zuck makes the sort of open source pitch, Satya follows up with, look, it's not a religion, it's about what customers want, and they want interoperability. So this makes a lot of sense coming from Satya because Microsoft's business and how they ultimately deploy software and service their clients, especially on the enterprise side, is more about giving them optionality, as Azure is more of the distribution layer. So Zuck's going to ask him about Azure here in a second and how they're differentiating in AI. So let's jump into that part and kind of hear what he has to say.
Yeah, so what's basically kind of the pitch or the role that you see Azure playing for open source, but I guess across all of these? It doesn't need to be exclusively that. So for developers who are getting started, like where are the areas that you're trying to differentiate and be the best?
So the first thing is, it's not like an AI workload just has an AI accelerator and a model that, at inference time, right? Because the reality is, in fact, if you look at underneath any AI workload, there's storage, right? There is other compute than an AI accelerator, and there is a lot of dependency on the network and so on. So the core infrastructure. So for us in Azure, we want to build compute, storage, network, plus AI accelerators as even infrastructure as a service that's world-class for someone who wants to be able to build the next generation of agents.
So here Zuck asks Satya what Azure's angle is in all of this. And Satya's answer is all about infrastructure thinking, right? Talking about how AI isn't just about the GPUs and models, but it's also about storage to hold all of the training and inference data, compute to run all the queries, networking, and all of the various other tools that particularly an enterprise and a SaaS needs to have to ultimately run AI, monitor it, manage it, and scale it securely. So that's really where Azure plays in all of this. As a cloud computing platform, it powers thousands of companies, SaaS tools, enterprise IT stacks, and now increasingly a bigger part of that is AI workloads. So their differentiation in business isn't about owning the model, it's all about owning where the model runs. So, the same way that AWS became the backbone of the startup boom, Azure is positioning itself as the operating layer for AI at scale. And what's smart is they're staying model agnostic. So, whether it's OpenAI, Meta, or your own internal model, Microsoft wants to power it ultimately.
Then above that, we're also building with Foundry an app server. Like, for example, every platform shift of ours, there's been an app server. How do you package up all the services, search or memory or safety, all of these services that are needed for someone, or evals. These are all things that every developer is trying to go do. So if you wrap them all in, frameworks for them, tools for that, that's, I think, the core.
So here, Satya goes a layer deeper and talks about where their Foundry platform comes in. So ultimately, Foundry is their kind of AI layer, and it's a suite of services within Azure that allows dev teams to ultimately manage models. So everything from governance, security, audit logs, data segmentation, what have you, are all built into Foundry to help developers ultimately manage these models. So this is also a really big deal when you think about startups working with enterprises and actually doing business with these companies, right? Because from experience, I can tell you one of the first things that firms will ask is, what's happening to my data? How do you manage security? How do you make sure my data is not going out into the wild? And Foundry is basically a toolkit for developers to answer all of that, be compliant, have strong security, etc. Basically, do everything they need to run these models and ultimately build tools on them without having to worry about the minutia of, again, compliance and some of these other items.
Knowledge work as well. So in our case, with Copilot deployment for knowledge work, if you take sales, like, one of the things I always describe is let's say I'm getting ready for a customer meeting. The workflow of how I get ready for an enterprise customer meeting has not changed since 1992 when I joined Microsoft, right? Basically, someone will write a report that'll come in email or will be shared in a document, and I'll read it the night before. Now I just go to Researcher and Copilot, and I get the thing which is the combination of what's on the web, what's internal, and even in my CRM, all done in real time. Right? But that's a change, and there's no need for somebody to prepare anything just because it's all available on tap. Yeah. So it requires you to change work artifact, and workflow, and that's a lot of change. And it happens slowly at first, and then all of a sudden.
So I love this as a real tangible example of how AI can reshape workflows. So Satya talks about prepping for customer meetings and how it's basically been the same since the 90s, right? So the old way was someone builds a prep document, they email it around, you read it the night before, and then you go to the meeting. The new way, at Microsoft at least, is you open Copilot, which is one of their internal AI tools. It pulls together real-time data from your CRM, internal documents, the web, and you get an instant brief tailored to that client with context and what matters today. So it's not just that it's convenient, but it also predicates a workflow change, right? So the work artifact that used to be a Word doc, right, is now something more dynamic and looks different, right? So I think that this is one of those things where Satya talks about workflow and the need to change, and how, again, people need to actually adopt these tools and consider how they're going to use them, right? It doesn't just happen automatically.
I saw that with the PCs, right? I think about how the world did forecasting before email and Excel. like interop, the faxes went around. Yeah, I guess you never lived that world.
I was in middle school. Yeah, no, it's.
But there was a world where people sent around faxes and people went and did inter-office memos, and then somebody said, hey, I'll send a spreadsheet in an email, and people enter numbers. And that changed how people did forecasting. And that's, I think, what we're at the very beginning of.
So this part's actually pretty hilarious because, like Mark, I never worked with a fax machine or did anything prior to email. But I think Satya's comparison of forecasting before Excel and email is a great example, right? So it's inconceivable to us to fax spreadsheets around or send documents that are real paper and then people be manually doing forecasting. But that's how people used to do things, right? So when we try to envision what our workflow is going to look like with AI, it's hard for us to do, and we probably can't even conceive how it's going to impact our day to day. So I thought that's just a really good example and kind of heuristic for us to use as things are changing with AI from a workflow perspective.
In terms of the coding and how it improves that, do you have a sense of how much of the code, like what % of the code that's being written inside Microsoft at this point is written by AI as opposed to by the engineers?
Yeah, so there are two sort of things we're tracking. One is the accept rates itself, right? That is sort of whatever, 30, 40, it's going up monotonically. And it depends, like one of the big challenges we had for a long time is a lot of our code is still C++. C Sharp, and C Sharp is pretty good, but C++, it was not that great. Python is fantastic. So we've now get better at that. So as language support has increased, the code completions have gotten good. The place where the agentic code still, it's sort of nascent. For new greenfield, it's very, very high. But as I said, nothing is greenfield.
So here they kind of get into the AI coding piece, which I think is really interesting. And Satya suggests that probably 30 to 40% of AI suggested code is accepted by developers. But he also kind of brings in a perspective that I hadn't really thought about, which is AI for greenfield code versus legacy code like Microsoft has. So Microsoft, being a company that's been around for, nearly 50 years here, has a ton of legacy code, and it's a lot harder for AI to actually manage that versus when you're doing greenfield work, right? And you suggest something to it and it ultimately just gives you what you want. So that's a challenge that I hadn't really thought about, and I feel like that's a pretty big competitive advantage for startups and new companies when you think about the speed at which they can execute and how AI kind of gives you an advantage in greenfield opportunities.
And so I'd say maybe 20, 30% of the code that is inside of our repos today in some of our projects are probably all written by software. What about you guys?
I actually don't have the number off the top of my head, but I mean, it's, I think, I think a lot of the stats that people say are still effectively of this like autocomplete variety.
Yeah.
But we have a bunch of teams that are working on basically doing feed ranking experiments and ads ranking and like very contained domains where you can study the history of all of the changes that have been made and like and make a change. And that I think is kind of an interesting area for us to work in.
Right. So here it's pretty interesting. Satya basically says 20 to 30% of the code is written by AI, which again, that's kind of mind blowing when you think about where things are at. And I also thought it was interesting to hear Mark Zuckerberg's kind of take on how much of their code is written by AI. So obviously he couldn't say specifically, but he had mentioned they're more focused on kind of tangible vertical use cases, right? So feed ranking algorithms, ad optimizations. And I think that that's really interesting. Again, just kind of the strategy difference from Microsoft to Meta. It's really for Meta about where AI can drive impact in their business, right? So yeah, again, really interesting stuff.
But the big one that we're focused on is building an AI and a machine learning engineer to advance the Llama development itself, right? Because I mean, our bet is sort of that in the next year, probably, I don't know, maybe half the development is going to be done by AI as opposed to people, and then that will just kind of increase from there.
So this to me seems like the biggest part of Meta's AI strategy, which is actually building an AI engineer that can help them improve Llama itself. So specifically here, he says, right, that he thinks half of the Llama development will eventually be done by AI itself. So when you think about what that means, it's like actually making changes to the model architecture, optimizing training, evaluating performance, and then, improving itself, right? So it's sort of like the Skynet sort of AI science fiction that we think about. That's pretty much what he's talking about here. But again, it's really interesting to see that they're investing so much of their time there.
Yeah, no, it's a very interesting concept, and I mean, I tend to think that like every engineer is effectively going to end up being more of like a tech lead in the future that has sort of their own little army of
That's
engineering agents that they work with.
Yeah.
But yeah.
So frankly, this is my favorite line from the entire video. So Zuck drops, again, another kind of like sci-fi Skynet type concept, which is engineers will be tech leads managing a fleet of AI agents to do the work, right? So that basically means when you're a single dev, or maybe you aren't even a dev, you have your own development team that's able to execute on all of the tasks for you. So maybe you've got 4 or 5 agents. One's focused on the UI, one's focused on database, one's focused on testing, all of these various different functions that have historically been people. We might actually have, individual agents able to do this, right? So for me, I think that that's just extremely exciting and it opens the door for a ton of possibilities, right? So solo founders being able to build tools themselves, right? Non-traditional, non-technical people being able to build real products. And ultimately, companies being able to scale what they're doing from a development perspective way more. So I think people oftentimes think about, the lack of jobs that we'll have, but in reality, maybe we'll have just as many developers, maybe more, right? Because now more people have the ability to actually develop software, and we're just building unfathomable amounts of software and, new products, new services with AI. So that to me is just, one of the coolest things. And again, it's really a mind-blowing concept.
Trends unfold, and there's all this hype around AI, and I feel like you've been able to kind of see through that and make very rational investments at each step along the way. And one of the points that you've made is that, okay, there's all this hype, but like really at the end of the day, if this is going to lead to massive increases in productivity, that needs to be reflected in major increases in GDP. And that this is going to take multiple years, many years to kind of play out. And I'm curious how you think, what's your current outlook on sort of what we should be looking for to understand the progress that this is making?
So here I really like this shift in the conversation too, because it takes it from kind of the AI maximalist discussion that we were having to more of the brass tacks and the rubber really hitting the road, right? Like if AI is doing all these incredible things, then ultimately that should be showing up within the GDP numbers and you should be seeing that reflected. So I know Satya is a big proponent of this, but I'm curious to see his take.
And how we would, and kind of like where you expect that to be over like a 3, 5, 7 year period.
To me, I think that's right, because to us, I would say it's a pretty existential priority, quite frankly. The world needs sort of a new factor of production and input that allows us to deal with a lot of the challenges we have. And the best way to think about it is, hey, what would it take, let's say, for the developed world to grow at 10%, right? Which may have been some of the peak numbers during, let's say, the Industrial Revolution or what have you. And for that to happen, then you have to sort of have productivity gains in every function, right? In healthcare, in retail, in broad knowledge work, in any industry. And for that to happen, I think AI has the promise, but you now have to sort of really have it deliver the real change in productivity. And that requires software and also management change, right? Because in some sense, people have to work with it differently. People always quote what happened with electricity, right? It was there for 50 years before people figured out that, hey, we got to really change the factories to really use electricity differently, right? And that is the famous Ford case study. And so to me, we are somewhere in between. I hope we don't take 50 years. But I do feel that by just thinking of this as the horseless carriage is also not going to be the way we're going to get to the other side.
So people who are more economically inclined than technically, I think that this really puts into perspective the size of the shift that's being expected. So Satya compares AI to the Industrial Revolution. And, again, if you think that those things are like for like, then GDP growth ultimately in developing countries should be hitting nearly 10%. So let's pause for a second, because today, 3% GDP growth within the United States is considered phenomenal, right? And in most years, it's closer to 1.5% and 2%. So 10%, that basically says AI needs to deliver a step function leap in how productive the world is in every single industry, right? And Satya, reinforces this. He says it's not just about software, it's also about how every single sector operates. And he compares it to electricity, right? Where the technology with electricity existed for 50 years before factories actually redesigned themselves to include it. And it wasn't until, Henry Ford, with the kind of invention or innovation of the assembly line, that you really saw the productivity gains of electricity within factories. So again, it's really good comparison, and I think it's super insightful when you think about the fact that AI, as great as it is, isn't going to deliver this type of performance gain in GDP unless companies actually change their workflows, management adapts, and you really redecide how decisions are made bottom up, right? It's not just going to happen automatically.
All right. Well, maybe a good note to end on is just, when you look at everything that's going on, I mean, I'm curious, what gives you like the most optimism, or what are you most excited about over the next period for what developers are going to be doing over the next few years?
Yeah, I mean, look, I always take my inspiration from that Bob Dylan line, right? Which is either you're busy being born or you're busy dying. It's better to be busy being born. And especially at a time like this, I think what gives me optimism is, even with all the various constraints, it turns out software in this new form of AI is still the most malleable resource we have to use to go solve these hard problems. And so that's what gives me the optimism.
Yeah, I'm not a huge Bob Dylan fan, but I am a Timothée Chalamet fan. So shout out to Timothée Chalamet. But I think that quote makes a lot of sense, right? That you can either worry about the disruption of AI or, like Satya, be optimistic about it, right? And be one of the people who's being reborn or building the future. And he also mentions, look, obviously this needs to touch other parts of the economy, but software is in the best position right now to utilize AI. So it starts there.
I also sort of say that's the call to action, I think, for the people in the room and for all of us, is to be able to sort of take the opportunity to lean into this, but then also build solutions. When I look at whether it's an IT backlog in a company or the unsolved problems in the real world, both of them need something new. And in order to work that, and that's where I think the greatest benefit of all of this tech is, and it'll only come down to developers in particular being able to go at it fearlessly.
Awesome. All right. Well, thank you, Satya, and thank you all for coming out. This has been an exciting day, and I'm very excited about what we're all building.
All right, so there you have it. The AI State of the Union comes to a close. You had a front row seat, and I think it was, again, really compelling. There was just so much good feedback and knowledge in there, and I highly encourage you to watch the full video, especially if you're a bit techier, because I did pick some of the parts that were a little less techy, believe it or not. So with that, we'll wrap things up. If you like this breakdown, hit the like button, consider subscribing. and follow the channel. We're posting new videos every week, unpacking the biggest shifts in business, technology, and strategy. So with that, thanks again for the watch. Have a good one.